Hello everyone, welcome to another Python video. In this video, we're creating a simple factoring program. And really the overall general purpose of this video is really looking at the simplistic essence of Python programming, where we get to write a simple script that does something that we want. And what we want right now is to find the individual factors of a given number. So we have really two goals here. Number one, we're going to grab an integer from the terminal when we interact with their code, and we're going to call that num. And we're going to find a way to analyze all the numbers from 1 to num. And if any numbers from 1 to num can evenly divide num, which was our input, then we're going to declare that it's a factor and output that to the terminal. And our final goal is going to be make it run a little faster. So let's get started. We're going to create a variable called num here, and we're going to set that equal to an int input. And a nice thing about the input function is the following. You can put a string inside to display a message on your terminal to give it like an instruction of what should be inputted. So we're going to say enter a positive number, like so. And if I were to run this program, which I've called factoring.py, that string message that I wrote within our input as an argument is going to be written right there. And anytime you're running a program, you can just do Control-C to kind of exit and interrupt your code. So I'm just going to do that. What the int is doing is converting our the result of our input into an integer, because we are working with a number. I'm not working with a string. And just remember that input always reads values as a string, and this is int, or converting our input function result into an int. Then we're going to find a way to analyze all the numbers from 1 to num and inclusive of num. All right, and a very easy way to do that is twofold. We're going to use range of 1 to num plus 1. Range is a built-in function that generates a sequence of integers. So range generates sequences, it generates a sequence of integers into our system memory. So right now what we're saying is currently we're going to start at 1 and go up to, but not including the right side value. That's how it works. So for example, if I did a range of 1 to 10, inside our system memory, which we call random access memory, RAM, is going to have these values stored inside our memory at the moment, and we're going to generate those and populate that inside of memory. And notice it's going to go up to 9. It's never going to include that last value. So it's inclusive start and exclusive end. Therefore, if we want to just generate all the numbers from 1 to num, we're going to add +1 there to make sure that we stop. Now, we need a way to look through this sequence of integers. For us to do that, to look through, or to in computer science, we call that traversing. In Python, we can use a for loop to traverse a sequence like so. And since we're doing a for loop, we're going to put a colon there because we're going to start a new code block. So right here, a for loop, moreover a for each loop. What it does, it generates a named temporary variable. In this case, x. X will represent each number in our sequence one by one until the end of the sequence. This ends up creating a loop because we execute our code within our for block, for loop, per each representation for x. All right. So what this does is we create a temporary variable x, which we need because we need to somehow grab and represent the values that are within this sequence. So if our num was 10, or the ending was 10, x is going to be representing 1, and we will be able to use that and manipulate that for that execution. And then x is going to go and represent number 2. So we're going to be able to loop this structure, right? So to just show you, I'm going to say that a formatted string of x is now x, and print I am looping still, and my for loop here, and then print I am done looping. All right, so let's see what this executes. So if I were to say Python factoring.py and actually run this code with 10, we did a +1 here, so it's actually going to include 10. At our very first loop, it outputs x is now 1. It's outputting this print statement right now, and it says I am still looping. All right, I'm looping still. And then x is now representing 2, but we're still in this loop. And as you see, we are repeating the block of code that is belonging to our for loop at this moment, while x is continuously changing and representing each individual values within our sequences of integers that we created with our range function. And this is really nice because we had to analyze all the numbers from 1 to our given user input of num because we wanted to find factors. Okay, so I just wanted to show you how this our for loop runs. And here I'm just gonna turn them off because I want to do something else with them. But just to show you how this happened, we have all this here, and I just commented that out. Awesome. Now to check if a number can evenly divide by another number, we can use the modulus symbol. So we can say if our given input here, and we divide it by x by using the modulus, and if the remainder ends up being 0, that means it's evenly divided. So any two numbers are evenly divisible if their remainder after a division is 0. All right, so that's what we wrote here. Any two numbers, we're taking num and x, are evenly divisible if the remainder after their division, so we'll say their division, it's 0. Okay, so we're taking this num. Currently, it's going to be 1. We're going to do num modulus x. That is equal to 0. Then we have a factor. Then we can say print f. We can say x is a factor of num, and we can write that now. So if we run our code and give it like a value like 12, you can say that 1, 2, 3, 4, 6, and 12 is a factor of 12. I'm just going to close this message now, turn that off, and whatnot. Okay. And this is a perfectly valid code, and this is a very simplistic code because if I got rid of all my comments, we would have 1, 2, 3, 4 lines of code for us to have a permanent solution of a Python script that can determine the number of determine each individual factors that any positive number has. Okay, and this works relatively well for somewhat large numbers. So if I have 12,345, this will be able to, quite quickly find those factors. But we run into a problem when we have somewhat of a large number. So right here we have 1.2 billion, right? We have 1.2 billion, right? We have some number that is astronomically large by comparing to like a number like 12, 1.2. And if I were to run this code, it's going to start to stall. Whereas in our previous execution, it was able to find our factors pretty well, but we are having trouble finding our factors quite fast. So what we want to do is, well, how can we make this faster? And that is also where we start going from just being a Python programmer and more of thinking like a computer scientist, where you think about optimization, efficiency, and algorithms. Okay, and one of the ways to do it is to kind of reduce the number of checks that we have to do, because in our for loop currently at the moment, when we are given a number, we are just continuously asking if 1 is a factor, is 2 is a factor, is 3 is a factor, if 4 is a factor. We are linearly checking every single number from 1 to our given number to see that if that number is indeed a factor. We want to reduce that, Okay, and the solution really comes from the fact that when we multiply a number, it's a two-number operation. We take one number and multiply it by another to get our result. Therefore, if I know what my result is, if I know that 1/2 of the number that we need to multiply by to get that number that we're interested in, well, then I can just divide our our number of interest with the number that's been already found as a factor to get my other half. So if we were to say we were if this was true, if this statement was true, I can also say that, well, print f let's say the other. We can create a variable called other, and you can say that other, which is just num divided by x, is also the factor, because we know that x is evenly divisible by num. Then the other side, the other number that we need to multiply x by to get num, would be just num divided by x. So we can say that other is also a factor of num. Okay. So let's clear. And then we can run this again with 12, and this is the result that we get now by adding these two lines of code. We have found that 1 is a factor, and then with that single 1, we're also able to say that 12.0 or 12, well, it's 12.0 right now because we did a single side division, is also a factor of 12. When we found that 2 is a factor of 12, we were able to find 6. And when we found 3 as a factor of 12, we also found 4. And then it starts to get repetitive. We are doing repetitive calculations to find it. And at this point right here, we could have actually stopped. Now you're wondering, well, how do we know for all numbers of all numbers, where is that stopping point? And some mathematicians, some computer scientists have figured out that the best place to stop this is utilizing the concept of a square. Right? Perfect squares will have a factor where their squares, or the square root of that number, can multiply each other with itself to generate that number. For example, let me just show you a perfect square. In this case, it's a 16. When we take 4, we can multiply by 4 again to generate that number, because both of them are the same, and that's why 16 is declared a perfect square. By utilizing that concept, if we were to take any number and find the square root, that will be our stopping point to help us say that, hey, we're going to generate 2 factors for our given numbers at once and to do less work. And we're also going to try to not repeat ourselves by having this nice little stopping point. So now I can turn this off and make a more optimized for loop. We can say our stopping point is going to be math.square root of num. And that will generate a decimal. So I'm going to convert it to an integer. And we're going to add 1 to it so that I don't have to do add 1 like so. But for us to use math.square root at the very top of our program, we're going to do import math. Now, if you did not want to do that, I'm going to say this is the alternative way. We could also say that stop is equivalent to taking num, giving it a exponent of a half, which is the exact same thing as a square root. We're going to convert that to an integer and then add 1. Then underneath, we can say for x in range from 1 to stop, I can now execute this code. Right? Therefore, if I were to execute this code now, we're going to say with 12, 1, 12, 2, 6, 3, and 4, those are our factors of 12, and we have checked significantly less numbers. Our for loop goes through 1, 2, and 3, so it does only 3 iteration, whereas our previous solution of checking all the numbers from 1 to num, we were actually doing 12 iterations, so we're actually having less code being executed during our runtime, which is the purpose of studying computer science, to improve already pre-made algorithms and so forth. Okay. So yeah, that is what I want to talk about today in this video, where how we can translate from being just a simple Python programmer into thinking about computer science concepts that we're going to delve into our future. Anyways, as always, thank you for watching and stay classy.